I want to move on to this next section and talk a little bit about SBOMs, because one of the main requirements that's in all of these different things for the European CRA, for CMMC within the U.S. government, and then this other thing that the government just released, which is basically a requirement for SBOMs, is SBOMs. So let's talk a little bit about SBOMs and what these are. Now, like all of you, NI has to go back and look at all of our products, and we have to look at it and say, are we delivering what our customers need? Now, at NI, we manage our product development through our different workflows, and each one of these workflows has behind it a roadmap. And so these are our roadmaps. And if you dig into any of our roadmaps, these are the kind of the customer-facing view of these roadmaps, but internally we have much more detailed versions of these, and all of them have roadmap for product security. So what are we doing to make our products more secure for customers that use them in these different spaces? And this is a really big topic of conversation among our R&D teams and leadership right now, is how are we going to respond to these changing requirements? So one of those main requirements is the SBOM. And so today, if you were to ask me, I can give you an SBOM today for our System Link product and for Linux RT, which runs on our cReal and PXI real-time systems. Soon, we are releasing an SBOM for LabVIEW, and then right after that, we will be releasing SBOMs for most of the rest of our software. So we've been working really hard to do this. Let's talk about what an SBOM is, and you'll see why this is kind of a big deal, because this is not as simple as just sitting down and saying, well, what installs with LabVIEW, right? What are the components? A real SBOM includes a lot more than just what are the installers that install with your product. So in this case, this SBOM is, so there's a document you can go look at, and there's a lot more to it than this, but I pulled out some of what I thought were the main pieces that you might be interested in. But an SBOM is a software bill of materials that is basically a list of what is in the software that you're selling us. And just like a hardware bill of materials will tell you what components are on that so that you can be ready to repair that if something goes wrong with it, a software bill of material tells you all of the things that are in the software so that you have an inventory. And that inventory becomes very helpful if there's an issue that arises later on. So basically, a software bill of materials is something that's machine readable. So it's in an XML format or some format that allows a script to be able to read that and then compile that into a broader set of requirements and notifications within a company. It's a list of all the components that are installed with the product, but also a list of components that are built into the product, and a list of any external services that support the software, right? So if I'm going out and connecting to some kind of an external server or database or something, having a list of all of those services is also critical. And then anything else that's necessary to understand the impact of a cyber attack. Right, so a few years ago, remember there was this big attack that was in the news about SolarWinds. And so SolarWinds was a company that they provide components out to lots of different software companies. And when it was made known that there was a vulnerability or an attack hidden inside of the SolarWinds, all of us who use SolarWinds, which is pretty much all of us, had to stop what we were doing and go in and look and see, are we using SolarWinds? Are we using that version of SolarWinds? Are we using it in a way that is exploitable by that attack? And we had to go through and dig through to see how much that was. It happened in December, so a lot of us had to spend like the Christmas vacation looking through everything to try to see, are we under attack by this vulnerability? And a lot of companies were. And so an SBOM is intended to provide that visibility faster and at a higher level so that when we hear that there's some kind of an attack, we can see immediately whether or not we are susceptible to that attack. And in fact, to automate that. So if I find that my component that I build has a vulnerability in it, I can report that into these public databases. Then those public databases can be tied to automatic scripts or tools that can look at those and look at my company inventory and notify my IT team immediately if there's been a reported vulnerability that we may be susceptible to, and we can dig into that. And so A software bomb allows us to do that. Now, so there's a question here, and then this is kind of what we're trying to figure out here is like, what is in an SBOM? But if you look inside of an SBOM, it will tell you what are the different components, right? So things that install with your software, right? So when you install LabVIEW from NI Package Manager, there are a bunch of things that install with that, where you might install .NET, for example. So that would be something we call out in our SBOM to say, when we install LabVIEW, it installs .NET, this version, and that version is necessary for what we do. It will also include, depending on the level of SBOM that you get, it may include other kinds of components as well. So if our developers in developing LabVIEW go out to GitHub and they grab and copy some code from there, some component there, and copy and use that code inside, so it doesn't install with LabVIEW, but it's actually buried inside of the source code of LabVIEW, that's another component, and that would be listed out in a detailed SBOM. When you're using, especially the open source software, but also third party, it would include license information. So in one place, you could look and see, if I use your software, what license obligations am I taking on myself? You know, what are all those license agreements that my users are clicking through? Any other kinds of release notes, or how these things work with each other, and what the life cycle is. Is this component that you've used, is it still supported or not? And then that then connects into tools that use that information to go to these public databases and pull down known vulnerabilities. So are there exploitable issues that have been reported? What are the details of that? How risky is that? What advisories are out there? And exactly what versions does that cover? So using that information, it can compare that with your SBOM to tell you how much you are actually at risk. And so an SBOM is becoming this requirement legally for some industries. So if you sell to the U.S. government, then over the next couple of months, you're going to have to provide these for every time you deliver a system to the government. So if you are a system integrator and one of your customers is the U.S. Navy or the Air Force or NASA, or you're selling to some of their contractors, so you're selling to Lockheed Martin or you're selling to Raytheon, then these SBOMs are going to become a critical part of what you have to deliver as part of that. You don't get to choose this anymore. And it's not clear yet in any of the regulation language how we're going to deliver this. We just know that we have to make it available. So NI is working on these, and so like I said, NI has these available now for SBOMs for System Link and for Linux RT for Compact Rio and other PXI real-time. To get those, though, we haven't decided where to make those available. So today, if you want those, you have to email us, and we'll give it to you. The LabVIEW one is coming out soon, and I don't know that we've made a call on exactly how we're going to deliver that to you, so that for now is probably going to be ask us. As we become more comfortable with it, we're going to figure out where to put that. Do we put that in the README? Do we put it on a website? Exactly where does that go exactly? And for our other products, those will all be out too. Maybe by the end of the year. These are things that we're looking for. Sam asks, is that for the IDE? It is for the IDE. And so for that development version, and the component list for the runtime version is really kind of the same thing. So, so it'll cover both of those. It will cover the LabVIEW 2024. It doesn't necessarily cover previous versions, but it will cover 2024, and from now on, we'll have all of those things. Now, Sam asked a question about, well, what about SBOMs for things that you build using LabVIEW? And that's a great question. And part of that answer is going to come from the presentation that Hunter is going to give us a little bit later on. Part of the answer is what's going to have to happen is when you build a LabVIEW application, you're going to take the LabVIEW SBOM and you're going to put that into and call that your SBOM. You're going to take any LabVIEW drivers, add that in, and that'll be another SBOM that you'll include. And then any other software that you install, either open source or third party that you purchase, when you grab that and put that in, you're going to have to track all of that. And some of that we might be able to do with NI Package Manager. But as we do this, some of what Hunter is going to show us will help us with creating those third party, for those complete SBOMs for your complete application. Now, this brings up an interesting question and problem for all of us. For us as a company, this is a huge issue. For you as a customer, this is going to become a big issue as well. Once we make SBOMs available and we say these are all the components, and you're checking that, you automate that to go into public databases, you're going to find immediately that there are lots and lots and lots of vulnerabilities that are out there that you just didn't know about before, but that are on your systems. Now, there is a difference between a vulnerability and an exploitable vulnerability, right? So things can have a weakness, but maybe there's no way to take advantage of that. A good example is that if you go to a website and it has a database link where you can put in a search field, one of the ways that people hack into a website is that in the search field, they'll put a database search term instead of just a term, a database command. So you can put a database command in, and when the search passes that back into the database will actually execute that database command. And you put a bad command like delete all data, well, now you've broken the system, right? So it becomes not exploitable if you use your database call, if you scrub that out first and remove any database-like commands, right? Now you're not able to exploit that vulnerability. So vulnerabilities may be exploitable by the way that you use them, or just inherently by the type of vulnerability that it is. So don't be worried that there's so many vulnerabilities. But if you look just this year to date, I looked a week ago, and so far this year there's been 20,000 different vulnerabilities posted to this public website. That's more than 100 every day. Some of those do relate to the components we use inside of LabVIEW. And so if you were to run an SBOM just today, you're going to freak out about the number of vulnerabilities that are out there. And if your IT team sees that and they freak out, they may come in and say, wait, we can't have any vulnerabilities on our system. You got to shut it all down. Well, that's not really true, right? Again, it's only an issue if it's exploitable. And rather than taking a panicky, we can't have any vulnerabilities, we're going to have to work together to figure out how we're going to manage this over time. Because I could ship you a version of LabVIEW maybe tomorrow that has 0 vulnerabilities. And a week from now, it'll have 100 because somebody's reported a bunch of vulnerabilities in the components that we use inside of LabVIEW. And we'll go through and we'll issue a fix for that, and we'll do what we need to do to provide those kind of updates. But when we do, how are you going to manage that on your system, right? This becomes a really big problem in test because when you change the code on your system, it may change the behavior of your system. And if you're testing something that has a big mechanical system in it and it's flipping around and doing all the things that it does, you can't afford to have a delay because that's got an additional encryption check in it or something else. You can't have it change the behavior of your system unless you go back and you apply, unless you go back and revalidate all of your systems. And so let's look at a couple of these questions. Here's a couple of good questions. So how do users of previous versions of LabVIEW secure their environment? This is a really big question, right? So we will introduce patches for LabVIEW according to our published life cycle, which is to go back basically 5 years or 4 years, and we'll issue patches for that. We can't go back much farther than that because these vulnerabilities compound over time, right? So now we can go back and fix the vulnerabilities in LabVIEW 2023 because there's several of them. If I start going back farther and I go back to like LabVIEW 2017, it's going to take me thousands. There's going to be thousands of things that we have to go back and fix, and that's the amount of engineering effort that it would take to go back and fix all of these things that are building up over time is just unfeasible. And if I were to fix all of those, the way that we have to fix some of those is that we upgrade those components, and upgrading those components makes it a new version anyway. And so even if I did try to tell you LabVIEW 2017 is going to, we're going to support it, it's not genuine really to be able to do that. You're going to have to revalidate even an old 2017 system, even if we call it LabVIEW 2017. So our life cycle is kind of the same as industry. If you look at Python or .NET or any of these other things that are out there, the typical life cycle is 5 years. Microsoft does have a longer option available for up to 10 years, but the industry mostly is centered around 5 years, and that's what we're shooting for, and that's what the European CRA is actually going to require is a 5-year support. And so we'll be able to provide that support. And when the way that our package manager works is that you do have to download the entire patch, the entire installer, but it will only apply the updates that need to be applied into it. That's the way that the package manager inherently works. And so it will only update those components. I'd be really nervous saying you don't have to validate if that's all you do. I would be really nervous to say that because you never know what one of these components is going to change slightly the timing or something like that inside of one of these systems. And that validation cost is going to balloon and become just absolutely immense. And so this is where there's a big difference between IT and OT systems, right? Your IT team will say, well, let's just update this every few days and we'll call it good. And we're going to stay up to date. And this is why, like my laptop, I get an update from Windows every week. I can't turn it off. And it happens at the most inconvenient time for me. I go to boot my computer up for an important meeting and I have to wait an extra 5-10 minutes because it has to run some update. That's fine for IT, right? I can wait a few minutes to send an email. If I'm in the middle of a test and or if even worse, if I'm in the middle of a control system and I have to do this update, it takes 5 or 10 minutes, and that's 5 or 10 minutes that things are offline, that's kind of a bad deal. And so we've got to figure out how to balance this between IT and OT. And so I think one of the solutions, first of all, is to understand which vulnerabilities actually matter, which ones are exploitable in the way that you're using it, right? So when we issue a patch in LabVIEW, we'll explain what is the issue and how did we patch it. And when you get that report, you need to look at this and say, am I using that component? If I'm not using that component, it may not be worth the downtime to install that update. So you need to understand what's exploitable, and we need to understand in our system whether that's exploitable within the LabVIEW ecosystem at all anyway. Of course, ideally, you plan these updates during your downtime, and you have the opportunity to test those updates, but sometimes you can't, and sometimes you just can't make those updates, and so you have to figure out how do I manage around those vulnerabilities, right? So some of these vulnerabilities might be related to like to the web server. Well, maybe you don't use the web server, and so is that update absolutely critical for you? Probably not, but you may need to go in and disable the web server as part of that. So there are conversations to have that your IT team will not understand, but you need to have with them to explain how to better defend your security strategy. Going back to 800-82, I thought there was a couple of good quotes from that. This one here, for control systems, it's much easier to penetrate and compromise critical infrastructure. There's a little or no security in those field devices. This is the issue, right, in these control systems. I would say the same thing is true for test systems. Generally, there hasn't been great security in these systems, and now we've got to go back and figure out how to do this. The problem is this quote here in the middle, the way that test systems are funded and maintained is not a model that supports ongoing security. That's a quote from me. That is absolutely true. This is the biggest problem we have, and I've gone to several security conferences where the DoD is there, and they're talking about how they want to be secure. And I've made this point to some pretty high-level people in the government that if we don't change the way that they're funding our projects for what we deliver to the government, they cannot expect ongoing security. Ongoing security costs money. It costs money to install updated components. It costs way more money to do the actual validation on those systems. And so the one and done type of funding that they provide for a lot of these systems today is just not feasible for the future. And that again, creates a pretty big issue for all of us. So let me pause there for a minute. Any thoughts, comments, questions about any of this? So there'll be a new version of LabVIEW coming out. We have scheduled updates every year. We have a couple of updates, and with our next version, I expect to see an announcement about SBOMs being available. And then after that, you'll start to see other SBOMs becoming available for our other products. You'll be able to adopt and then use, but you'll have to build on top of that while you're using these things. So question here, is there guidance on the artifacts required to show compliance with the requirements? That's a really good question. And one of the things that, when we say artifacts, I think it's kind of evidence. What are some of the things that you can provide? One of the things that we've done is gone through to create, for some of our products, and we're working on more, to provide documents that show here is how LabVIEW meets the NIST 800-171 requirements, one by one. All 110, here's how it meets each of those. So we've done that for the LabVIEW runtime engine. I've done that for SystemLink. We're doing that right now for the NI Linux real-time for the operating system that's used on real-time and on PXI. And so we're looking at these things. Constantine asked a couple of good questions here. So can you apply security updates to older versions of LabVIEW and TestStand? Not really, because when we release a new version of like LabVIEW, what we're doing is we're taking all of the old components. So we're not just adding a couple new features and releasing it. We're also going through the full list of all the components. And we're taking like this Apache server and we're updating the Apache server to the new version. And when we do that, there's often new calls and new hooks that we have to make inside of LabVIEW. So, and we have to revalidate it. So a new copy of LabVIEW is not just new LabVIEW code, but it's also new components and new ways of using those components. And sometimes we have to disable things, right? If you go back to LabVIEW 20, I don't remember what year it was, but older versions of LabVIEW used Silverlight. We don't use Silverlight anymore. We have a lot of the same functions that Silverlight supported, so we had to replace Silverlight with something else that can do some of the things that Silverlight did and do it in a whole new way. That's a lot of new coding in LabVIEW that looks like and ends up being the same thing. So if you go back and try to apply components from the new version of LabVIEW into those old things, they don't work, and they may have been replaced by a newer component or newer type of component that is just simply not compatible. Can you disable components you don't use? Sometimes. I've had a couple of customers over the last year come to us and say, hey, we can't run because it has this component, and that component, my IT team won't let us install that component. And if you take off just that component, and then you try to launch LabVIEW, LabVIEW starts up, and in looking for that component, it fails, and so it's not able to run. Now, if you're not using a component, then, and I hesitate to say this, but we have worked with customers to give them kind of a patched launcher that will launch LabVIEW without looking for that component. That's really risky to do because you may not know all the ways that that component is used. And a lot of components, there's no way to disable it. Like one of the components might give you your interface and it won't even launch without it. If you disable that, you have no interface, it just won't launch. There's just simply no way to do it. So unfortunately, it's not as easy as just saying, well, we won't use that component then, because they're not function calls. They are things that support the way that LabVIEW works at all. But if you do come across a situation where there's a component causing you a problem and you simply cannot update, contact me and we'll see what we can work out together and see if we can come up with a plan. But as we go forward, we're going to all have to shift our mindset, including our customers who don't fund things correctly. We're going to have to shift our mindset away from how do we use this old system as long as possible and shift more to the IT mindset, which is how do we keep it as up to date as possible in order to be secure, right?
Great answer. Thank you, Steve. We live in a new world now.
I know it's not a great answer because it's hard, but it's the truth, right? And it's the balance. And I don't know the answer of how we're going to do this, how we're going to balance long-term life cycles that we need with ongoing security. They're just completely at odds with each other. Any other questions or thoughts about that? All right, I'm sure you're tired of hearing me. Here's a good one. How's data at rest being handled for these things? Disk encryption. Excellent. So good question here from Chris Rust about our Compact Rio. We did give a presentation at NI Connect specifically on Compact Rio security and what some of the challenges are and what we need to do. I'm actually working very closely with our R&D team to create a plan, a couple of plans. A short-term plan, which is how are we going to do this in the short term? And actually Cyril, who's on the call here today at Neosoft, they've figured out a couple of these things, and they're working with C-Reals to make C-Reals more secure. And they're actually working with our R&D team. We're trying to give them the advice that they need to help provide a short-term solution for things like disk encryption for these devices. And but also communication encryption and a lot of other things that have to happen inside of our CREO devices. In the short term, what I think we're going to end up with is a way that you can, like a set of instructions that you can configure your CREO and grab some third-party components that make your CREO secure. Longer term, we are working on how do we make the out-of-the-box experience from CREO be secure, so you turn it on and it's rock solid secure. And if you want to enable features that make it less secure, you will be responsible to make it less secure, rather than the other way where you have to make it more secure. And so we're working on that. In fact, my next meeting after we finish here today is I'm meeting with our president of our company to pitch that idea and to get the funding and the resources that we need, which I'm absolutely confident we're going to get. We have a pretty good plan for that. But it is hard, and we have to be, we are working towards that. In the short term, if you have a need for that CREO stuff, contact me and we can talk through that short-term plan and the things that we're working on. We plan by August to release kind of an informal beta set of configuration requirements, and by the end of the year to have formalized and fully tested that configuration as a recommended configuration that you can take and use to make CREO fully secure. And then after that, to release the out-of-the-box secure version. Is anyone working with any industry players? Any industry players for security scanning, like Black Duck or Tenable, to understand what anybody flagged on this bomb? Yeah, we are working with some of them to talk about that. It's a little harder than that. Those I'll just say yes, but we haven't been totally successful with those conversations yet. We have a very different business model. We have a very different type of product, LabVIEW being what it is. So let me just say, we're going to talk about a lot of this in Hunter's presentation. So good question.